So yeah, my name is Gary, and I will talk about web stuff. I'm actually glad that so many people survived yesterday's party. I was not expecting that. Anyway, first a disclaimer. I'm a penetration tester at Siemens, but this talk doesn't have anything to do with Siemens. That's just nice to know. And I will suggest a game for today. I don't think it's really appropriate in this time of the day because it's a drinking game. But you can still participate if you want. The game is that you need some alcohol, and whenever I say the word request, you drink. It's gonna be funny because I'm talking about web things, so I will say request a lot. So just try it. Then, what's really the talk is about? So, it's about the cross-origin resource sharing, which I will call CORS, because it's a really long word and I don't like long words. I will introduce CORS, and I will talk a little bit about what was before CORS, how it was solved before it existed. Then I start to go into the security part, by a little bit trying to define the threat and define the attacker and to tell what's really the problem here. Then I will describe a few attack scenarios where this feature can be used. And then to be a good guy, I will talk about the solution as well, what you can do to avoid these attacks. And at the end, I prepared some demos to see. So, what's CORS? CORS is an HTML5 feature. It's actually partly a feature in a browser, partly in a server, and it's part of the XML HTTP request, what you use in JavaScript. The whole idea is to load content or resources from other domains than the one where you run your script at the time. It's because before CORS, that's what we had. So I have a magic wand here. So there were this web server logic where you ran your data, and you had to store all your stuff there, like images, videos, whatever. You had to store everything in your domain because you couldn't reach out of your domain from JavaScript or whatever. Because there was this really cool thing, the same origin policy, which stop you from connecting to different domains. Now, today it's a bit problematic with this approach because many companies want to store things, other domains, like they have outsourced storage, like storage in the cloud, where they store all their images, all their videos, because it's faster than their own services, so that they can download it faster. They couldn't do that before CORS. It was really complicated to actually download the stuff from the other domain. So that's why that was the business need for implementing something like this. Of course, when there is a business need, people will solve it. However, but they will. And there were some solutions for the same problem before CORS was existing. They were mostly hacks. Like not security hacks, but like programming hacks. One example is like having a proxy in your own domain, which you send a request to this proxy, and then the proxy will download the data from wherever it is, and then serve it from your own domain. Or there was this JSON-P, which is JSON with padding. The whole idea was to exploit the fact that when you load a script tag in a browser, then here in the source attribute, you can reference external domains. So there will be a GET request sent there to download the data from there, and it will be executed here in the script tag as JavaScript. So what people did in JSON-P is that they tried to build kind of an API on this fact. For instance, if you look at here, you see that it's something about users, and there is some kind of ID, and at the end there is some parameter, So what you can guess that probably this user, the user with this ID is downloaded, so the details of this user is downloaded from that server, and this here is usually a callback, because what you got back from this call is here. This is the content of the response. So you get the details, the user details here, and it's rubbed around with your callback. Because if it's rubbed around with this JavaScript callback, then it can be executed immediately as JavaScript. Of course, you need to have the implementation of this callback function in your own code. So this more or less works, but I think you also feel that this is not really how things should work, that you like use a random attribute to get out of your domain and then wrap it around with the callback and things like that. So for me, it looks really like a hack. So so because of that, course was made. So the cross-origin resource sharing. And how it works, first you need to define two different kind of requests. The naming is not too clever. It's actually not really, it's named like something like that everywhere. So there's a simple request, and every other request is the not simple request. So and the browser has to make a decision whether in case of an XML HTTP request, we are talking about a simple request or not a simple request. This decision is actually not that difficult to make, because the simple request has really strong rules how you define them. So a simple request is either a head, a get, or a post. It can contain only these headers, and the content type can be only these three. If a request, so if an XML HTTP request complies with these rules, then it's a simple request. If not, then it's not a simple request. The browser will evaluate these rules whenever you try to do an XML HTTP request send. So, but the not simple request, that's a bit tricky. I will go just a bit back. If it's a simple request, you say to the browser, I want to send this request. The browser looks at it, oh yeah, that's a simple request. Then he can just send it. So the browser can just send the request to the server because it was simple. If it's not a simple request, then it's a bit more complicated, and then we came to this diagram. So you see here, this is a XML HTTP request. You say here, send this request, then comes the browser, check the rules. It finds out that this is not a simple request. Then he has to discuss it somehow with the server what to do in this case. So the browser will send a pre-flight request to the server, actually asking the server whether such a request like yours is allowed or not. The server will respond, telling the browser that I will accept this and this and this and this and this kind of request. And then the browser here makes another decision whether the request what you sent is allowed by the server or not. And if it's allowed, then he will send the original request what you set here. So this request will be just sent here. And then it happens, as always, the server will do whatever you asked for, and then you get a response back. And then do whatever you wanted with that. And so the pre-flight request looks a bit complicated at first, or at least it looked for me. But it's not that bad, actually. This is a pre-flight request. It's always an options request. And there is an origin header. We always have an origin header if we talk about cores, because that's the way to tell the server that this request is coming from a different origin. And then there are a bunch of access control request headers in the request. This is like, so this pre-flight request is actually asking the server whether a put request with some funny header is allowed or not. And the server will respond with this. This is not the full response, just the appropriate headers. The server will say that through these access control allow headers, he will say that I will accept requests from this domain, that this can be a list. So from these domains, and I will accept these methods, and I will accept these headers. So that's how the server tells the browser what he accepts. And in this case, using this prefied request response, the browser will make the decision whether to send your original request or not. So mainly that was course. Now we go a little bit into the offensive word. First, I'm going to define how to think about the attacker. The whole goal is this attacker model and things is that if you deal with course, so if you have to work with it in your job, then you can like think about what kind of risks there are, what kind of attackers you can expect. So this is a really basic diagram how like a web attack scenario could look like. There is some attacker here. He compromised the server somewhere on the internet where he can put his own JavaScript code or HTML code or whatever code. And these are our target users. They are sitting probably inside some precious intranet, some company intranet or something like that. So there are services to attack here, and there are services to attack here outside. So that's the basic architecture. So now the attacker. It's important to talk about what the attacker knows. If it's really an external attacker who is, it's like not in your company, so he doesn't really know about your internal things, what kind of internal services you have. He doesn't have information about what he can steal from you. But if it's an internal attacker and he sits inside, he doesn't have to be sitting in your network, but the point is that he knows what to take. So he knows, for instance, that you have where you store your business plan or where you store your roadmap for the next year or the financial data. So he knows exactly what he wants. He also can have different goals. The simplest goal is to get access to your network. You sit in the internet, so the first step would be to somehow get access to the network. Even if he knows what's there, even if not, he wants to get access to just to look around. He can also attack the internal services, as I said, and yeah, generally he wants to steal something probably, either from you or from your company. And this is the last point about the attacker. He either sits in your network or in the internet. There are some differences, but in case of course, it's not that extremely important, but it's connected with the thing what kind of knowledge the attacker has. So what is the problem? Yeah, you can see that why I didn't go into the photoshopping industry because yeah, I'm not really good in that. But anyway, the problem is what I kind of mentioned before, that we had this same origin policy, which was pretty straightforward. You cannot talk with different origins. If you download an HTML with JavaScript in it, you're not allowed to go to other domains and get stuff. Now, Course is kind of breaking this rule. It's officially breaking it, so it's not really a hack. It's not a. Actually, I have a slide for that, but it's not a vulnerability. So Course is actually a well designed feature, which is not broken. It's just something which, as an attacker, you can use as a tool. It's not a vulnerability what you exploit. It's a tool what you can use in different attacks, and that's what I think not everybody is expecting, because I think for me it was pretty new some times ago that such thing exists, and it kind of breaks the same origin policy. So I think it must be new for some other people as well, and I think that's the point, to get to know it and then think about it when you are in a case like this. Yeah, attack scenarios. you probably expected that mostly you can use it in cross-site request forgery. That's the CSRF here. I will call it CSRF because, again, it's a long word and I still don't like the long words. But I will just summarize it. Some of you might know, but some of you might not, how it works, this attack. And that's why I just wanted a slide to summarize it. So the point is that, for instance, here are our target users, and here is like, for instance, Facebook. And let's assume that Facebook is vulnerable to cross-site request forgery. Probably not, but let's just assume for the sake of example. So what this attacker wants is to post something on your wall on Facebook. So for that he somehow has to send a request with your session cookies when you're logged into Facebook. Now, the browser automatically attaches the cookies to request when you're sending it to somewhere. So if the attacker is able to send a request to Facebook in the user's browser, then the session cookies will be attached automatically. So, so what the attacker does is that he creates a fake HTML form which would post something on your wall. He puts it here, and when you load this page, the form will be submitted automatically. So then he tricks the users here to load his malicious website somehow, so that's some kind of social engineering. And then the form will be submitted, so there will be a request sent to Facebook. And since the browser here, so this page is loaded here in the browser, when the browser sees that there is a request sent to the Facebook, he's like, oh, good, I have cookies for Facebook, that I will just attach these cookies to this request, and then everybody's happy. And since Facebook doesn't really have the chance to check whether this request is really from the user or not, then he will just post the thing on the wall. So that's how CSRF attacks work. There's a fake form which is submitted. The browser when the user loads it, the browser automatically attaches the session cookies, and the service will do whatever it was asked for. So, and related to that, we have a couple of attack scenarios. What I'm sure you can imagine many more. I just wanted to have some examples here where you can use the cross-origin resource sharing as a tool of your attack. First one is the multi-stage CSRF. So when I say multi-stage, I mean like shopping, like web shops. If you want to buy something, first you have to put it in your shopping basket. Then you have to fill out your address. If you're logged in, you might have your credit data already filled, but you still have to click on like, yeah, buy this item, and that's it. That means that this is 3 stages. So as an attacker, you have to send at least 3 requests. Without JavaScript, it's kind of difficult to do this. It's possible, but it's difficult for the attacker to implement such an attack with so many steps. But if you have JavaScript, and that's what the cross-origin resource sharing allows, to use JavaScript in your attacks. Then you can, so in JavaScript you can do whatever you want. So you can just create the requests and send them in the appropriate order, and that's it. So it's easy to do such multi-stage things. And cross-domain data theft. We will see in one of the demos that one goal is to go to another domain, steal something from there through the user, and send it back to you. Because you can get the user to connect to a different domain and download data from there. That's what we can do. And then you can like send it back to yourself. Complex JavaScript attack scenarios is like the multi-stage is kind of that. But you can imagine many more things where the thing what you want to do in an application is pretty complicated. You have to do a lot of things, and you can with one or two forms, you cannot do that. But what if you have JavaScript in your hand, then you can do all of those. And for instance, Beef, the browser exploitation framework, it also uses cores when it does pivoting. So when Beef compromises another machine, then it uses cores, so JavaScript request, and with that cores to talk with this compromised service. So with his own shell on the other machine. And you can also do things like network enumeration, so kind of like doing an Nmap from a browser. Of course, it's not that smart as an Nmap, but still you can start like sending requests to different IPs and sending and different ports, and based on the response and the response time and things like that. So it's a bit of guessing, but still it's possible. So that means that an attacker who sits outside the network can do network scanning just using JavaScript if the user loads his page. And the last example here is the file upload CSRF, and for that I also have a slide with lots of information. And so if you ever try to do file upload CSRF, it's not that simple, because usually to do CSRF you make a fake HTML form. So that's what you use. You make a form, and then this form is going to be submitted, and that's how you send your request. However, when you use the upload form of HTML, then it will generate a multi-part request, and this is one part of such an upload request. So this is the content of the file. So that's how a file is sent to the server. And the interesting part is this file name part, because with normal so if you want to fake this request with using normal HTML forms but not upload forms, then you can even fake these multi-part requests, but you cannot put this thing here, because there is just it's not implemented in an HTML form. So, and because of that, you cannot do malicious file upload with using just an HTML form and not an upload form. So, and actually I had this in a pen test, and the application was pretty simple. There was like a login page, and then there was a file upload page, so, and nothing else. And so obviously I wanted to do some kind of malicious file upload, and that's why I started to figure out how this works. So this is not really feasible without using JavaScript, and this is the solution for this problem, for the file upload, because if you can use JavaScript, and with cores you can just create the whole request in JavaScript. So what you see here, that I'm creating the XML HTTP request. It's a post, and it's a multi-part, and here is the request body, and then here I put everything what I want, and then I submit it here. And at the end, if I want to do something with the response, I could, but I didn't. So this is how this CSRF page would look like. And when the user comes here and clicks the submit button, then this file will be uploaded, what's defined here in the JavaScript code. So with that, you can do malicious file upload. You don't even need the user interaction. He just needs to, you need him to open your page, but you don't need him to click on submit button or anything, because you can also do that from JavaScript. And funnily, first when I had this problem, I wrote this script myself, but just the next day the burp suite was released with a new version, and they just implemented this here. So actually this was generated with the burp suite Pro. So now if you want, you can do like course based proof of concept CSRF attacks, like this one here. There are limitations, because as I said, the feature itself is not broken. So we will have to deal with some kind of limitations, and sometimes the attacks are not going to work because of these. The first one I call the write-only request, because the thing is that if something fails during the course negotiation, then you still get the response from the server, but you won't be able to read it in the browser. So it will not be delivered to the JavaScript code. So the browser will receive it, but it will not give it to the JavaScript. So even, for instance, if you go to Firebug, you will see that the request is sent. You see that you get a response, but even in Firebug, you cannot see what was the content of the response. You will see it in Wireshark or in Burp or in any proxy, but not in the browser, not with JavaScript. And these are the rules which I found so far which can have this effect. One is if you don't have this access control allow origins header. That means that the server is not configured to work with CORS. So CORS is not enabled on the server. Then it will not deliver this header, and then the browser will take that as like, yeah, CORS is disallowed, so the response shouldn't be delivered to the user, to the JavaScript code. So you just don't get the response. Then the second is the source origin is not, this is again the access control allow origins, and this is also that, just really long words. And so the source origin is not listed in this header. Then that means that the course is enabled on the server, but the origin where you're coming from, that's not. It's just that simple, and then it's pretty easy to understand. Then the response that's because of that will not be given to the JavaScript code again. And the last step is, I haven't really talked about this with credentials, but it's a really interesting feature. You can tell the browser with this is an attribute of the XML HTTP request. And with that, you can say with credentials equals true. And with that, telling the browser that please send the credentials with this request. It's like telling the browser to attach the session cookies and attach the authentication headers and whatever credentials are saved for the destination domain. But one good thing here is that if this with credentials is true, then, but if the server response replies with the access control allow origin equals all domains, this little star sign, that means that the course is enabled for all domains. So if the with credentials is true and the response contains that it's for all domains, then the browser won't show the response to the JavaScript. And it was really surprising for me that it works this way, although it's a good way to go, because actually if this line wouldn't be implemented, then the CSRF protections, what we are using right now, usually wouldn't work. Because then you could just go to a service, CSRF protection is usually like generating a random token and putting it in the HTML page, so that when the form on that page is submitted, then the server can check that it contains the random token for that exact page. So with like preventing replay attacks and things like that. But if this wouldn't be implemented, then you could just, before sending your malicious request to the server, you could just first request the form itself, and with that you would get the CSRF token, and you could just put the CSRF token in your attack request. And with that, like, really like breaking the whole CSRF protection. So it's good that this rule is here. But again, bear in mind that the request is still sent, and the request is still calculated or like understood by the server. So for instance, if you say that you want to add the user and you send an add user request to the server will add that user and send back the response. You just won't see the response in the browser as the attacker, but the user will be still added. That's, I think, a very important thing, and that's why it's called write-only, because you write, but you cannot read. Yes, and this previous slide was about simple requests. And this one is about the not simple request, so when we send a pre-flight request as well. If anything is wrong with the pre-flight request, then the browser will just simply not send your original request. So if you're whatever, like if you wanted to, you want to send a put, but then the server replies that he doesn't allow put, just get and post, then the browser will just not send your request. It's so easy. So in that case, there is no write and no read. So that's also a pretty strong limitation. Actually, if you're using course in attack, you want to stay in the simple request area, which is not that difficult, but you have to pay attention. And yeah, solutions. Just to try to do something good for the word and for the word piece. First, to just make people understand course, and I'm actually trying to do the first part right now, just to tell people how course works and how it should be used. Then, if you're using course, you want to do as strict rules as possible. So you want to really think about why you're allowing course and set the rules as strict as possible. It also with the credentials. If you need to think about whether you want external domains to come to your service with credentials. If that makes sense for you, then yeah, you can allow it. But if not, then reject it. And an important point that there is a bit of change of mindset, because now this is also a developer's problem. So it's not really just a web server configuration. It also exists in a web server, but it's also, you need to think about it as developers, not only as operations. So if you want to harden yourself, you can do it either on a web server or a container or whatever layer, or you can do it in your application. So for instance, hardening Apache, you can do it with these mod headers, and you can configure it either in htaccess or the config in these directory location files and virtual host parts, and you just have to set lines like these. You know, it's like this is telling the Apache that you will allow only the example.com to use course, and every other course request will be rejected from by this web server. And as I said, you can also do this in your application. And for instance, this is just an example, ASP.NET code that you just attach the appropriate headers. So like if you cannot make general rules how the web server should react on such requests, because it's somehow connected with your business logic, then you might want to do it in your application and check whether it's allowed, and if so, then add the appropriate headers. Yeah, there is a demo. Yeah, I didn't want to sacrifice any animals for the gods of demo, so I made videos instead of doing it live. But that's good because then at least I can talk during the demo. So this is, if I see my notes. Sorry. This is the Sugar CRM. This is a CRM application. You can test it online as I did. And what I want to do here is that you see Jane. I was logged in as Jane, and I'm a regular user. And now in the other browser, I'm logged in as the admin. And you see here that Jane is, yeah, a regular user. So the attacker is Jane, and she wants to be an administrator. So what he does is he actually she wants to submit this form here, to edit this form as the admin, to give herself admin rights. So that's what we are gonna try to do. And one interesting thing was here, this token, this cookie at the bottom. You can't really read it. It's a cookie from Amazon. I didn't know at the time, but it's from Amazon. But the funny part is it's only valid for 60 seconds. But whenever you set a new request, you get the same cookie again. But it was like an unintentional protection against CSRF. Because if an attacker didn't have this valid cookie, so you had only like 60 seconds to submit, to make your attack, because otherwise the cookie would be invalid. And to work with this problem, we could use cores. Yeah, this is the attack page. I don't know whether you can read it. Anyway, so this is an HTML, the one like what you have seen before, and the first part here, yeah, we'll be back. But this is the form. This is the form what you see on the web page to edit a user, and this part here is to just request a random page just to get the cookie again. And after you do this request, you will have 60 seconds to do the other request to change the user rights. Because then you will have the cookie for 60 seconds. And then the second request, it says with credentials true, and here is the admin, is admin equals 1. So if this request is successful, then Jane is going to be an administrator. So let's see it. So we will load this malicious page as the administrator. So Jane tricked the administrator to submit this form here. And as the admin is submitting it, first you see the first request to get the Amazon cookie, and then you see the second request to actually set the user rights. And we will see the request in Burp. Yeah, you see that it's totally simple GET request without any cookies or anything. And in the response, you see that you got the new cookie with the time frame for the next 60 seconds. And in the next request, you see that all the appropriate cookies were attached. So the Amazon cookies and all the credentials, because I said that please with credentials in the JavaScript. And then isAdmin is equals 1. And the response is just a redirect, so it was successful, but let's see. Just reloading the page. This is the interesting part. Now we are admins, just reloading it here to see whether it was successful. And yes, you could see, or I don't know whether you can see, it says system administrator user. And then we go to Jane's session in the other browser and just reload her page. And yeah, suddenly she became a system administrator. Yes, this is the second demo. It's a wiki because there are always wikis in every company where they store the very important information, like how to take over the world. This is my wiki at home, so this is how I want to take over the world. And the attacker's goal in this case to steal this secret plan. So what he does, wikis are usually readable without authentication. You just need to authenticate to edit the wiki site itself. So,
excuse me, can I have a small question?
Yep.
Just to your previous sample, to your previous demonstration. Did you assume that Amazon accepts CORS requests from any domain?
Actually, that's really interesting because it wasn't really up to Amazon. It was just running in Amazon, so it was up to the services. But that's also the trick here.
So assumption is that the service deployed at the Amazon accept CORS requests from the domain which we want to attack. Okay.
It accepts requests from the domain where my attack is.
Where your attack is, no,
Yeah,
where
so
the victim of your attack is located. Because you basically you lured the guy to your website.
Yeah, exactly.
Okay.
But then it's my my website runs in my domain, so the target service has to
Okay.
accept my domain.
Okay, thank you.
And yeah, so the first part is just a simple request without credentials to download the page, so to download the secret plan, and because this page will be loaded inside the internal network in the user's browser, all this JavaScript will be run there. So that's why I, as an attacker from the internet, doesn't have access to the wiki, but the user who executes this, he will, and that's why I can steal it. So the first part is just to download the page itself, and the second part is actually posting it back to my site. So it's just, there is this writer PHP, and whatever I send to the writer PHP, it will be written in a file. This is the writer PHP. You don't want to use it because it's like probably vulnerable to everything. Really. So it will write the incoming data in this incoming .html. So now we are, again, we trick the user to open our web page from the internet, and he gets a really innocent web page, but as soon as he hovers over the nice pony pictures, something is going to happen. And you see that there was 2 requests here. First, to download, we will see that in Burp shortly. First, to download the content as I described, so to download the secret plan. For that, there was no, cookies were not needed. And since the access control L origin was set to all, then because of that, JavaScript could read the response. So then with the second request, the response was sent to my site as just the content of the request, and we'll see shortly that it's going to be there. So it should be at incoming.html. And now you see that the same page is now on my website. That's the point here. And yeah, and that was the presentation, so I thank you. Do we have some time for questions, or rather do it outside?
Yeah, I think just two questions.
Are there any questions?
Everyone is shy, come on. Just maybe one question.
There was some half question, yeah?
So I guess you need the browser to support CORS.
Yeah.
So
yeah.
what is the current state of how well is it supported now?
It's so basically, if you take the newest version for every browser, all of them support it in some way. With IE, there are some tricks because of the different kind of XML HTTP requests implementation and stuff like that. But generally, it's supported. If you're interested in that, there are quite a few tables on the internet to check from which version different browsers started to support it, also including mobile browsers and stuff like that. But generally, right now, all of them support it.
Okay, thank you.
You're welcome.